going down, volume's going down. You could all boring. Or I could say, this is a balloon. Yes, it's a dog. Ooh. Okay, I should have my gloves on. Don't put Temperature went down, volume went down. Now I'm in room temperature. Volume's going up, or temperature's going up. Volume's going up. Done. All right, now you are all going, there we go. Now you're all going to remember that volume and temperature are directly proportional. I could have gone for 20 minutes on that microscopic explanation, or I could have done this. It takes 1 minute, and now hopefully you are going to remember that for the rest of your life. But now here's the thing. You always have to do something else. You can't just show it to them. You have to do something else. So the question is, will this work with something bigger? Well, let's try it. Okay. Shout out to Nikki for getting me helium balloons. Thank you, thank you. Okay, so here's my octopus. I had to cut a leg, so it only has 7 legs. Please forgive me. Okay. Ooh. Ah. Ooh. You guys are an easy crowd to impress. All right. So now again, we're just trying to talk about volume versus temperature and see if that works. And so what I like to do is just change it up a little bit. Right? So we use legs. It doesn't have to be just the dog. In this case, it's an octopus with 7 legs. But then what I like to do is throw a little bit of fun onto it. Come on, come on. Yes, there you go. Come on, dude. It's trying. It's trying. Let me encourage you. Oh, snap. He's a little cold still. But in theory, that's a cool octopus, right? Yes? So if the students don't know that the head is filled with helium, the second it starts floating around and usually chasing me if I can get the wind current correct, and be like, oh, what's happening? Oh, my goodness. They are now curious, right? Back at you. Yeah, there you go. So now they're curious, and they're going to remember. And so you can take this to another conversation and say, why? Why does it float? Well, now you're talking about density. Now you're talking about helium. Now you're talking about the concentration in the atmosphere. So many different reasons. But what they're going to remember, volume and temperature are directly proportional, and octopuses are awesome. Okay, that's what they'll remember. Is it octopi? Wait, oh. Moving on.
Okay, so don't film anyone in the class, okay? Is that the right way around?
Yeah.
All right, so let's have a countdown. Let's go from this way up and down. Okay, ready? So count me in. 5, 4, 3, 2, 1. You gave me about 5 seconds, and that's not long to wait. So you are putting my brain under some proper strain. I'm under a lot of strain because I have to disperse words into the atmosphere as if they can fly like pollen grains. And I know that I get under your skin like it's your biology. You can study my brain, that's my neurology. You can study my heart, that's cardiology. And I am a slow flow lyricist. I bring in the light when I'm swinging the mic. I bring in the light like it's photosynthesis, and now I'm moving down. I've got a body of work like physiology, and I was moving up. I'm under high pressure like cholesterol. I'm the best with flow, and I'm just here to let you know that every word that I can throw might just tie a bond to you. It gets into your nucleus and your cells and your every kind of cell, even your mitochondria, and I am getting these words as soon as I be rapping them. And if you put me in water, I don't fizz. I am not elementary potassium. I am oxygen, meaning I am everywhere. I am inside of your body, your blood vessels, your mind and your spirit. I am in the air. I am even in your nucleolus. So you should know this. I don't really want to come against you. You don't want to come against me when I MC. That would be an antagonistic thing to do. And my antagonistic muscles, they have strength. And I was going on through these words as I am reading them at length. And I am metallic, meaning I am strong like magnesium. Moving on. I don't know what cardiovascular means. Think it's something to do with my veins. So I have to really go back inside of my brain to think when I was doing biology GCSE. Now it still beats me. I'm moving on, and I can divide this class in half like multiple personalities of schizophrenia. I am blitzing through these words as quickly reading them, and I know that these words, they are flowering, they are blooming like geraniums. Rearrange the words slightly, we get a new element, germanium. So let's have a look all again, and I think that I've done what I've never dreamed of done. 1, 2, 3, 4, 5, 6, Or 17. Did you get it?
He's farther away than we are. Fuck. It's not good. That is so amazing. Is it bright?
No, I can't even see right now because it was so bright.
Pretty bright.
Okay, I hope you enjoyed it.
एक मोटी से पतली में वेव भेज रहा हूं, देख कुछ ऑब्जर्व करना, तेरे को अपने आप दिखेगा। देख उसमें वेलोसिटी ज्यादा है कम होनी चाहिए। देख यहां से जो ट्रांसमिट हुआ ना क्या चीज, वेव वहां बहुत जल्दी गई, देखना उधर ऑब्जर्व होगी तेरे को, कोई खास बात नहीं उस वाली पे। यहां से धीरे से वेव जाती हुई वहां फटाक से जाएगी, देखना। मतलब जो वेव इधर से इधर आ गई उसे बोलते हैं ट्रांसमिटेड, और जो पलट के वापस चली गई उसे क्या बोलते हैं, रिफ्लेक्ट। तो अगर अपन इसके बात करेंगे
And this guy, part teacher,
and two negatives make a bigger negative, -3.
part ringmaster, all innovator, founded the academy.
It's hard to.
Let's start with the building, a 50,000 square foot warehouse in South Atlanta, transformed into the sort of school J.K. Rowling dreamed up for Harry Potter. Every classroom has an elaborate theme. There's a dragon and a 2-story bungee jump. All 112 kids have to be slide certified, a symbol they've signed on for something different. He's a former National Teacher of the Year in Harlem, who opened the school in 2007. It's private, non-profit, grades 5 through 8.
Here I have some phosphorus. Phosphorus is a combustible material. It will burn quite readily. I'll place a little phosphorus on this pedestal here. Now, in order to burn, what does the phosphorus need? What does combustion mean? It means reaction with oxygen. If I light this, you will see that it burns. It burns quite readily. But air is only 20% oxygen. Here I have a flask that is filled with oxygen. The combustion is dramatically different inside pure oxygen. We have the reaction of phosphorus and oxygen making P4O10. I call this the glowing orb of chemistry. The glowing orb. This is how I determine grades. I stare into the orb. Now, my students should recognize that I have a closed system with a fixed amount of oxygen and a fixed amount of phosphorus. This reaction can only proceed until one of the two materials is used up. We call it a limiting reagent system. So the reaction can only continue until one of the two starting materials is consumed, and then the reaction has to stop! There we go!
Here. I trust the conservation of mechanical energy for 100%. I may not trust myself. I'm going to release this object, and I hope I will be able to do it at 0 speed, so that when it comes back, it may touch my chin, but it may not crush my chin. I want you to be extremely quiet, because this is no joke. If I don't succeed in giving it 0 speed, then this will be my last lecture. I will close my eyes. I don't want to see this. So please be very quiet. I almost didn't sleep all night. 3, 2, 1, 0. Physics works, and I'm still alive.
You use this X right here to get the. Oh my gosh! I just drew on that. Hold on. You know what? I'm gonna search for a solution. Let's see, video, math. Maybe this guy can help me. There we go. Hey you. Hey. Do you think you could help me? I accidentally drew on the screen right here. I don't know what to do. No, a little bit farther down, right there. Yeah, there you go. Oh, that's not working. That's making it worse. I'm not sure what to do here. What's that? Oh, okay, yeah, all right. That's just getting the cat dirty. That's not working. All right, okay, yeah, let's try that. Oh, it's okay, don't worry about it. I don't know what to do. You have an idea? Oh, okay. Yeah, all right. Okay, let me try that. Okay, go grab that for me. All right. Move out of the way. Let's see if I can do this. There we go. Okay, actually let me move this out of the way so you can see it there. Move that there. There we go. I think that worked. All right, thanks for helping me. Oh, yeah, okay. Sorry, yeah, okay. Sorry. Oh, wait a second. I think the lightsaber was too hot. Uh-oh. Ah, it's catching on fire. Oh no. There we go. Finally got rid of it. All right, thank you very much.
It's caught in the crossfire.